3.1 In Behavior, Zeros and Terns. Well, first off, let's just introduce a couple of definitions to you. We've used polynomial functions for years, but just to tell you what a polynomial function is, it's any function where it's in the form of, when you have the equation, it's f of x equals some number times x to a number plus b, x to a different number plus c, x to a different number, all the way down, where the main catch is whatever the power is, the power has to be a non-negative integer, which means it could be 0 or any whole number, positive whole number. It just can't be negative, and it can't be a fraction or decimal. It has to be whole numbers on that. A power function is any function where it can be written in the form of a number times x to a power that's a number. So a and the one catch here is a and n are both not 0. And we'll talk about that more on the next lesson of 3.2. So first off, let's talk about the number of terns. So we're talking about the extrema here, the max and mins. So if the function is x squared, that's a degree of 2. If the function is x cubed, that's a degree of 3. The function is x to the 4th, that's a degree of 4, and x to the 5th is a degree of 5. Well, if we go back and count how many times this turns, it was decreasing and then increasing, so there was one turn right there. This one has 2 turns. And this one has 3 turns, and this one has 4 turns. Now, there could be less, but at most, whatever the degree is, the number of turns will always be 1 less than that. It's based on the highest degree. So when you're looking at a polynomial function, you look for the highest degree, and 1 less than that is the maximum number of turns that graph could have. The number of zeros it has, well, is how many times it could cross the x-axis. So if this were the x-axis, this one could have 2 zeros. This one could have 1, 2, 3 zeros. This one could have 1, 2, 3, 4 zeros, and this one could have 1, 2, 3, 4, 5 zeros. So whatever n is, that's how many times that graph could have touch the x-axis and give you how many intercepts it could have. That's the maximum number. There could be less. When a graph bounces, like when it touches the x-axis and doesn't cross it, that's going to cause it to be less. To talk about whether a graph touches or crosses the x-axis, if we have to go back and look at the multiplicity. On the factored version, if you look at that power, this one has a power of 1, this one has a power of 1. The multiplicity is 1. This one had a power of 2, the multiplicity is 2. And at that -5, when x equals -5, or the factor of x plus 5, when it's an even multiplicity, if the function has an even multiplicity, the graph is going to bounce or touch the x-axis and go back the way it came. So if it's an even multiplicity, it touches. If it's an odd multiplicity, it crosses. And now let's talk about the end behavior. The end behavior, like this graph, went up on both ends. Well, the way you tell that is we have to look at what the degree is. And this one is an x squared term. This is an x to the 1st, and this is an x to the 1st. So 1x squared times 1x times 1x is going to be 1x to the 4th. So since this is a degree of 4, the ends have to do the exact same thing. And since the leading coefficient was positive, it's just like a positive x squared graph. It's up on both ends. And mainly we look at the right end. Whatever the right end does, if the leading coefficient is positive, it's up on the right. Then the left end depends on whether it's an even or odd function. Even functions will do the same thing on the left as it does on the right. Odd will do the exact opposite. We'll touch on more of that on the back side, but we need that to talk about on this next one. So looking at this one, number 1, f of x equals -3x squared plus 4x to the 5th minus 6x to the 6th plus 1. How many zeros could it have? Well, let's look for the degree. The degree, when you have separate terms, is the highest one. So that one has a degree of 6. That means there could be 6 zeros. And just to refresh your memory, the leading coefficient here would be -6. And since that's a negative leading coefficient, this graph goes down on the right. And since it's an even power, then down on the left also. So there's just a little hint on end behavior for you. So let's talk about number 2 now. Determine the zeros, the multiplicity, and the end behavior for the function. Well, luckily when it's factored, well, let's talk about the zeros first. One of my factors is x equals 0, because if this is 0, that whole term is 0. Another factor is x equals 3. And I'm going to write these down below. So x equals 0, x equals 3, and the last one is x equals negative 2. Those are the three x-intercepts. 0, 3, and negative 2. And let's talk about the multiplicity. At 0, we have a multiplicity of 1. Multiplicity of 1. At 3, we have a multiplicity of 1. And at negative 2, we have a multiplicity of 5. Well, since all of those are odd, the graph is going to cross through. Now, the end behavior, I need to know what's the leading coefficient and what's the degree. So this one is negative x times x to the 5th. Well, that's going to be a negative x to the 7th power. So since it's a negative leading coefficient, that means it goes down on the right. Since it's odd power and odd degree, it means opposite end on the left. And now we know at an odd multiplicity it has to cross through. So here it's going to cross through, and here it's going to cross through. I don't know how high or low to make these max and mins. I'm just making a general sketch of the general direction it goes. And this one goes up on the left and down on the right and only had 3 zeros. So to describe the end behavior, as x goes to negative infinity, that means as x goes to the left, this graph is going up. So the y values, f of x, is going to infinity. As x goes to the right, to positive infinity, the y values, f of x, is going down to negative infinity. On number 3, let's write the factored equation. Well, for this one, I see x equals negative 1, and I see x equals positive 2. So that means x plus 1 would be a factor, and x minus 2 would be a factor. And I notice it bounces here. If it bounces, it's going to be an even power, and we're going to go for the smallest even power, so that'd be x squared. Now, this one would be x to the 3rd, which is what this graph could very well looks like, but it goes down on the right. Down on the right means we need a negative. So is that all we need? Well, let's talk about one other thing, the y-intercept, because there could be a number here. So a lot of times we'll put an a, and we have to figure out what that number is. Well, that number is based on, let's use this ordered pair. And so we have the point 0, 2. If I plug in 0, I should get positive 2, because at 0, at x equals 0, y equals 2. So 2 has to equal to negative a times 0 plus 1 squared times 0 minus 2, which means 2 equals negative a times 1 squared times negative 2, or 2 is equal to, I could have left off the negative. Let's go ahead and keep going. So this would be a is equal to a positive, let's see, that's positive 2a right now. And if I divide by 2, we get a is equal to 1. So this tells me that this just needs to be a negative 1. So our function is just f of x equals negative x plus 1 squared times x minus 2. And in class when I did this, I didn't even worry about the a yet. I just said, okay, let's figure out this intercept. We know it's an even power there. And look at, if we look at this and plugged in 0, that's going to be, and we knew it was down on the right, so I knew that's negative. This would be 1. This would be negative 2. And that would be positive 2. So it's already, everything we need is right there. So there's no other value to worry about. The assignment, you don't have to worry about that a term. You just have to be able to identify the x-intercepts and a y-intercept, and whether it's down on the right or up on the left, or vice versa on any of those, and when it bounces and when it touches. So let's move on to number 4. So on this one, I notice x equals negative 3, which means x plus 3 is one of my factors. X equals 2. So x minus 2 is one of my factors, and x equals 4, which means x minus 4 is one of my factors. And I notice it passes through at this one and passes through at this one, but at this one it touched. So this has to be an even power. So for this one, I'm going to go ahead and put that a back in. So f of x is equal to a times x plus 3 times x minus 2 squared times x minus 4. Now to find out what a needs to be, let's put in one ordered pair that we know that we haven't already used, and that would be a y-intercept, would be a good one. When x is 0, that would be a times 0 plus 3 times 0 minus 2 squared times 0 minus 4. And we know when x is 0, you get negative 2. So right now I can solve for a, and that's a times 3 times 4 times 4. Oh, wait, 1, 2, 3, 4. That's a 5, not a 4. So change those. Who were you yelling at me when I did that? I apologize. I was like, that's not the answer I got earlier today. So 3 times 4 times 5 has to equal negative 2. And, oh, it's a negative 5. So that is negative 60a equals negative 2. Negative 60 divide by negative 60 on both sides. A is positive 1/30. So that means the coefficient in front that we didn't know for this problem, for our function, it's f of x equals 1/30 x plus 3, x minus 2 squared, and then x minus 5. And that's the function. Like I said, for the assignment, don't worry about figuring out this number. I'm just showing you that to show you good math along the way. But for the assignment, you need to know, does it have a positive y-intercept? And does it find the x-intercepts and decide whether it should be an even power or odd power? And that's pretty much will get you through most of those questions. Well, let's move on to the backside. Oh, here's our notes for end behavior. They didn't quite fit on the front, so let's review what we've already talked about. To worry about end behavior, you look at the highest degree, and if the number in front of that leading coefficient, if that number in front of the highest power, if it's negative, the graph is going to go down on the right, no matter whether it's an even function or an odd function. If it's negative, it's down on the right. If it's positive, it's up on the right. And then if it's an even degree, the left end does the same thing as the right end. It goes up on the left and down, or down on the left, depending on what the right end does. If it's an odd degree, it's always the opposite. So let's look at number 5. Let's talk about this one. Find the degree, the leading coefficient, and the zeros for f of x equals x to the 4th minus 36x squared. Well, I look for the highest power. This is already in a polynomial function form. So let's see, the highest power is 4, so the degree is 4. The leading coefficient is the number in front of that term. So the leading coefficient is 1. That right there tells me if it's a positive 1, the graph is going up on the right, and since it's even, it's going up on the left. So we would say as x goes to negative infinity, as x goes to the left, f of x is going up to positive infinity. As x goes to the right, f of x, the y value, is also going up. And now state whether it touches the x-axis or crosses the x-axis at each of those intercepts. Well, to do that, I need it in factored form. So I need to factor this. So this is f of x equals x to the 4th minus 36x squared. I look for the greatest common factor, and I see an x squared. So I'm going to factor out an x squared, and that leaves me x squared minus 36, which can be factored to x minus 6 and x plus 6. So there's the factored version. So that tells me my zeros. One of my zeros is x equals 0, because that would make this whole thing 0 if this is 0. One of my factors is x equals 6, and one of them is x equals negative 6. And the multiplicity, or state whether it touches or turns around, whether it crosses or turns around, whether it bounces or passes through, is based on the multiplicity. This one had an even multiplicity, so it bounces. This one had an odd multiplicity, so it crosses the x-axis. And this one had an odd multiplicity, so it crosses the x-axis. Okay, let's do that same thing, but it's already in factored form. Well, when it's in factored form, to find the degree, we need to look at the x terms, all the variables. If we multiply all those out, so negative x squared times x times 2x times x. Well, that is 2, 3, 4, 5, and a negative 2x to the 5th. So that tells me my degree is that highest power, And my leading coefficient is the coefficient in front of those terms, which would be negative 2. You don't have to multiply all the rest of it out to get the leading term. You look at just the x terms, because that'll be the highest power. And since it's a degree of 5, the ends are going opposite directions, and it's a negative leading coefficient. So that means down on the right, and since they're opposite directions, up on the left. So that would be as x goes to negative infinity, to the left, we're going up. F of x goes up, so you say infinity. As x goes to the right, f of x goes down. And to find the zeros, well, this one's already factored, so we have x equals 0, x equals 5, x equals, x equals negative 1/2, and x equals negative 2. Odd power, odd power, odd power, even power. So it bounces at the even power, and then crosses at all the others. Okay, well, let's practice what we've just done. Number 7a says find the degree. So look for the highest power. The highest power is a 3. That leading coefficient that went with it is a positive. Since the degree was 3, that's the maximum number of zeros this can have. And since the degree was 3, the number of turns is always, it can turn one less time, so the maximum number of turns would be 2. Since it's a positive leading coefficient, that means up on the right. So that means positive infinity to the right. And since it's an odd power, the left has to do the opposite. On 7b, let's do the same thing. Don't forget, if you want to try these, you could always pause the video and do these on your own and then check them, but I'm going to go through this one with you. This one for a degree is x times x squared times x. That is 1, 2, 3, 4 power of 4, so a degree of 4. And if we look at the coefficients, that's 1 times 1 times 1, which is positive. So the number of zeros, maximum number of zeros, the same as the degree. The turns is 1 less than that, so that's 3. And the end behavior, since it's positive, means up on the right, and even functions do the same thing on the left. And on 7c, the degree is the highest power, which is 8. The coefficient in front of that term is a negative 7. The maximum number of zeros, it could have 8 solutions or zeros, but only 7 turns. And since it's a negative leading coefficient, that means down on the right. And since it's an even power, the left does the exact same thing. And odd power would have to be the opposite. And then the last section on this one says I'm going to need a coordinate plane, so I'm going to draw that on both 8 and 9. And we'll switch colors for my graph. Sketch a graph of a polynomial function. So it's going to be continuous, so I'll draw it without picking up my pencil. And it has a positive y-intercept, so it crosses the y-axis up here. One local max, or one relative max, which means it's one top of a hump, one maximum, and one minimum, so bottom of a hump, but no absolute, which means that never stops going in that direction. So it has to have one top and one bottom. Could be like this right here. No maximum because it goes up forever. No minimum because it goes down forever. Has a positive y-intercept. And has to have a bottom of a hump and a top of a hump. And that's all you need. Oh, it did say also as it goes up on the right as x goes to the right. Which I did that, luckily. I wasn't paying attention. I missed that one almost. Number 9 says sketch a graph of a polynomial function that has a negative y-intercept, so it has to cross somewhere below the x-axis. One local max and one local min again, so one hump each. No absolute extrema, and y goes down as x goes to the right, so it has to go this way. So we could make it go like that right there. And it does. We don't know specifically where those humps are. I just know it has to have one hump in each direction. One valley and one mountain. And that is all you need to know to be able to do the assignment of 3.1. The notes are more tedious than the assignment. The assignment should be much easier, and it's just practicing all those traits. Good luck to you.